Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 6.3, which is going to deal with standard form. Now, standard form is the third and final form in which that we're going to write equations for linear functions. Now, for today, we have one learning goal, and our learning goal for today is that you will be able to write an equation in standard form. So we're going to take a look at standard form, and then we're going to run through how to write an equation in standard form. And then we'll just briefly touch on how to graph it. Okay, so for standard form, we have talked about standard form before when we had looked at section 5.2 on using the intercepts. So we have seen the standard form of an equation is ax plus by equals c. So this is what standard form looks like. A and B and C are all numbers. A and B cannot both be 0. For instance, the equation 2x plus 3y equals negative 12 is in standard form. Now, we can take standard form and we can write it into the other forms. Meaning I could take standard form of 2x plus 3y equals negative 12. I can turn that into y equals negative 2/3 x minus 4, so slope-intercept form, or point slope, which would be y plus 8 equals negative 2/3 times x minus 6. What this tells us, the fact that I can take this and write it into the other forms, means that I can take my slope-intercept and I can write it in this form, or I can take point slope and change it into standard form. And what that tells us and what that allows us to do is to take either writing an equation in slope-intercept form or writing an equation in point-slope form and then switching it to standard form. There's not a general equation for plugging in stuff to get your equation in standard form. You need to write it in either slope-intercept form or point-slope and then change it to standard form. So you have to write it like you did in section 6.1 for slope-intercept, or in point-slope like we did in 6.2, and then we will go through and write it in standard form. So a little bit of practice with that, so we have some comfortability with it. But if we look at example 1, example 1 is going to ask us to rewrite the equation in standard form. Now, standard form, again, is ax plus by equals c. Few things about standard form you need to be aware of. First thing is that with standard form, x and y have to be on the same side. So it cannot be y equals 6x, yet x and y are on the same side. You can only have x and y on the left side, and then the free number like this minus 4 has to be over by itself. Now a number can be on x and y, it just cannot be a fraction. So if there's ever a fraction involved, I'll show you how we get rid of that. Alright, so with that said, for part A, we need to take slope-intercept, which is y equals 6x minus 4, and change it into standard form. So I need to first get x on the other side. So because I have x on the right here, and it's a positive 6x, that means to do the opposite, I need to subtract 6x to the left. So when I subtract 6x to the left, that's going to go away on the right, and then I get a negative 6x plus y equals negative 4. So ask yourself this, are x and y on the same side? Yes. Is the number that's by itself, is that constant on the other side? Yes. Do I have a fraction? No. Because I have fulfilled all of those, this is my answer. Negative 6x plus y equals negative 4. So we can take an equation that's in slope-intercept form. All you have to do is subtract that x to the other side, and as long as there's not any fractions, then you are good to go. Now, if we take a look at B, for part B, we have it in point slope form. So the y minus y1 equals m times x minus x1. To change this into standard form, what you have to do first is distribute this -2. So when we distribute the -2, we get y minus 4 equals -2x plus 6. And the reason this turned to plus 6 is because if I distribute the negative, -2 times -3, negative times negative is positive, 2 times 3 is 6. All right, from there, what we have to do next is to move this number with y over to the constant over here. So I need to move this 4 over with the 6. Because this is a minus 4, that means I need to add 4. So if I add 4, I get y equals -2x plus 10. And I'm now at the point where I would be if I started with the point slope, or the slope-intercept, sorry. So from here, I just have to do like what I did over here, which is to add the 2x over, and I'm adding because it's -2x. So we add 2x to both sides. And when I add 2x to both sides, I get 2x plus y equals 10. And that is going to be my answer. So that is a quick demonstration to show you how we can change slope-intercept, like part A, into standard form, and how I can change point slope, like part B, into standard form. Now, both of those ideas will be really helpful as we continue with our lesson today. So let's go ahead and take a look at example 2 as we up the game. So for example 2, they're going to ask us to write an equation in standard form for each line. So for example 2, they're going to give us the slope and a point, and we have to write it in standard form. Now, when you go through and do these problems, you need to write it in slope-intercept or point slope first. I am going to give you an example of both, and then let you choose which path you would like or which method you prefer. There's 2 ways to do this. One way is not necessarily right. They're both right. I just want you to choose the one that you feel more comfortable with. So if we look at example 2a, we are told our slope is 2, and it goes through the point -2, 1, that it's on the line. Now, the first way that I'm going to do this is to use the slope-intercept form. So that means y equals mx plus b. So I'm going to use slope-intercept form first. Now, they tell me my m, and they tell me my x and y. So if I know my m, and I know my x and y, what we're going to do then is take those and plug it in and figure out what our b value is. So if I plug all that in, my y is 2, my m is 2, and my x is -2. So I have 2 equals 2 times -2 plus b. First step is we're going to go through and multiply these. So 2 times -2 is going to give me a -4. So I get 2 equals -4 plus b. Then to solve for b, we're going to add this 4 over to the left. So we add 4 to the left side. We get 2 plus 4 is 6. So I get 6 to equal b. I now have my m, I now have my b for my equation. So we're going to plug that in. In my slope-intercept form would be y equals 2x plus 6. Now, this problem asks me to write it in standard form. So that means I need to get the x to the other side with y to put this in standard form. So to do that, I need to move this x because it's a positive 2x. I'm going to subtract it to both sides. If it was negative, we would add. So when I subtract 2x to both sides, it cancels on the right, and I'm left with negative 2x plus y equals 6. Are x and y on the same side? Yes. Is the constant on the right just the plain number? Yes. Do I have any fractions? No. Therefore, I am good, and this is my answer. And that is how we're going to write an equation in standard form for each line. And that particular method is using slope-intercept form. So if you want to start with slope-intercept form, that is how you go through and do this problem. All right, so that is one method for how you go through and write an equation in standard form, given the slope and a point. Next, I'm going to show you the second method, and that's using point slope. So point slope, if you recall, is y minus y1 equals m times x minus x1. So what I need to do in this case is I need to take my slope, which in this case is 4. I need to take my point, my x1, y1, which is negative 3 comma 0. What I need to do for this is plug it into the equation. So y minus y1, so y minus 0 equals 4 times x minus 3. All right, so now that I have everything plugged in, at this point, we then just have to go through, distribute the 4, add the 0, and keep moving it around. So this is my answer in point slope. And if I simplify it a step further here for this problem, it's y minus 0 equals 4 times x plus 3. So that is my equation in point slope. To change it to standard form, again, we're going to distribute this 4 to both sides, or to both parts. So if I have y minus 0, anything minus 0 is just itself, so it's y equals. 4 times x is 4x, and then 4 times 3 is 12. So I now have y equals 4x plus 12. All I have to do is subtract this 4x to both sides. So when I do that, I end up with a negative 4x plus y equals 12. And that is my answer in standard form using point slope. So if you go through, like we did with part A, and you use slope-intercept, the y equals mx plus b, if you are given your slope and a point, you have to go through and figure out your y-intercept, so you have to figure out your b first. Then you have your equation. Then you just have to move the x to the left. If you use point slope, okay, you're going to take your m and your point, plug it in for y1, m, and x1. Then you just have to distribute the number in front of the parentheses, add the number to the other side, and then move the x to the left. Now, for you, it's just a matter of preference in which way you prefer. There is not a right or wrong method for this. It's which way you feel more comfortable with. So I'm going to leave that up to you on which way to choose. On my completed notes, I have gone through and done all the problems using point slope. The reason I use point slope is because all I have to do is just plug the points in, distribute, add, and then add or subtract. If you prefer to set it up like this, you can do that for part A. Now, parts C and D are the same idea. It's just they give you a different slope and a different point, and you have to go through and find the line. Now, what I do want to do is just one more, doing it with point slope. And then we'll move on to example 3. All right, again, point slope is y minus y1 equals m times x minus x1. So what I need to have is my slope and then an x1, y1. So they tell me my slope is -2. My x1, y1 is -7, -10. So now that I know that, we're going to plug all of that in. So we get y minus -10 equals -2 times x minus a -7. All right, before I go through and distribute, I'm going to go through and simplify my minus negatives. So this becomes y plus 10 equals -2 times x plus 7. All right, from here, your first step is to go through and distribute the number in front of the parentheses to the x in the other number. So I get y plus 10 equals -2x. -2 times 7 is going to end up with -14. My next step is I need to move this number, this 10, over to the right side. I need to get it away from y. So we're going to subtract 10 to both sides. So we get y equals -2x. -14 minus 10 is going to be -24. And my last step is I have to then add 2x to both sides to get x and y on the same side. So the x's then cancel on the right, and then I end up with 2x plus y equals -24. And that is my answer. So C is done much the same way as I did with B, where I used point slope. So I have a slope and I have a point. Plug in your stuff. All you have to do is distribute, move this number to the other side, and then move x to the other side. Now, before I jump to example 3, I got ahead of myself. I want to run through D, and I want to run through it using points or slope intercept, the y equals mx plus b. So that way you have another example of using it. So we start with y equals mx plus b. Your first step is to then go through and find your b. They tell me my m is 5. They tell me my x1 and y1 is -2, 4. So from here, we're going to plug all of this in for my m, my y, and my x. So we have y equals, so that's me 4 equals mx, so that's me 5 times -2 plus b. So we're going to go through and multiply this first. 5 times -2 is going to give me -10. So we have 4 equals -10 plus b. Then from here, we're going to add 10 to the left. So 4 plus 10 is going to give me 14. So that means 14 equals b. Now that I know that b equals 14, I have my m as well. My equation is y equals 5x plus 14. And then all I have to do is subtract the 5x to both sides. Cancels on the right, and then I end up with -5x plus y equals 14. Now, it doesn't matter which way you go through and do this, you will end up with the same result whether you use slope-intercept or point-slope, like I said, both methods are correct and they are both okay to use. It's just a matter of preference on which way you prefer to go through and get to standard form. Either you take your point and your slope, plug it in, distribute, add or subtract, and then add or subtract, and you get your answer. Or you take your stuff, plug it into y equals mx plus b, figure out your b, and then just move your x to the left. So, matter of preference to you on which way you would prefer to do that. All right, so that is example 2 when they give you your slope and they give you a point and how they ask you to write it in standard form. Example 3 is going to ask us to write an equation in standard form for each line when they give you 2 points. So the difference from example 3 to example 2 is they don't tell you your slope. So for these problems, we have to go through and identify our slope first, and then we can go through and write our equation in standard form. So whenever they give you 2 points, know that you have to go through and find your slope first, then you can go through and write your equation in standard form, like we did with example 2. So recall back to section 5.3, which I've recalled back to quite a bit here lately. We're going to use our slope formula, which is y2 minus y1 over x2 minus x1. So your first step when you were given 2 points in writing an equation in standard form is to go through and find your slope. So that's going to be our first step. So m equals my x1, y1 is going to be the -2, -1. And then my x2, y2 is going to be 0, 4. So my slope formula is y2 minus y1. So that's going to be 4 minus a -1 over x2 minus x1. So 0 minus a -2. All right, then from there, you just have to do your normal solving for the slope, where you simplify the top and then simplify the bottom. So 4 minus a -1 is 4 plus 1, or 5. And then 0 minus a -2 is 0 plus 2, or 2. So I have 5 halves. So now that I have identified my slope, I can then go through and write it in standard form, just like I did in example 2, where I take my slope and I take one of my points and I either plug it into slope or point slope form or slope intercept form. So you can use either one from this point and then change it into standard form, which is your ax plus by equals c. All right, for this one, I am going to use point slope to show you. The next one, I will use standard form, or not standard form, slope intercept the y equals mx plus b. So I'm going to start with y minus y1 equals m times x minus x1. So that is going to be my starting point. All right. To use point slope, I have to use my slope and one of my points. Well, my slope is 5 halves. I just need to decide which of these points I want to use. Doesn't matter which one you use, you get the same result. You can use the first points. I'm not a big fan of using negatives, and the fact that the second point has a 0, I'm going to use my second set of points. So it's y minus y1, so it's y minus 4. It's going to equal, my slope is 5 halves, and then it's x minus x1, or in this case 0, so it's going to be x minus 0. So my equation is now y minus 4 equals 5/2 times x minus 0. From here, we need to go through and distribute. So we're going to go through and distribute this 5/2. So we still have y minus 4 equals 5/2 x. And 5/2 times 0 is just 0. So it's just 5/2 x. All right, next step is that I need to move this 4 to the right. So I'm going to add 4 to the right side. So that's going to give me y equals 5/2 x plus 4. And then I need to move this 5/2 x to the left side. Because it's positive 5/2 x, I'm going to subtract it. So then I get negative 5/2 x plus y equals 4. So if we go through this, do I have x and y on the same side? Yes. Do I have the constant or the number by itself on the right? Yes. Do I have a fraction? Yes. So because I have a fraction, I need to get rid of my fraction. To get rid of a fraction, don't feel like it's going to be anything too intense. You just have to take this number on the bottom and multiply it to everything. So we're going to multiply 2 to everything. And when I go through and multiply 2 to everything, this fraction cancels out, so it's just a negative 5x. And then we just multiply 2 to everything. So 2 times y is 2y. And then 2 times 4 is 8. And that is our equation in standard form. Now, if for some reason they don't like the negative out in front, you just have to change all the signs. So another way I could write this would be positive 5x minus 2y equals negative 8. So that would be an alternate way to write it. Now, I know it feels like that's a long, drawn-out way to use point slope because that one took longer, but that's really just because it had a fraction. If it doesn't have a fraction, that does end a little bit quicker. All right, for part B, we need to go through and do the same thing. Now, part A, I used point slope. Part B, I'm going to use slope intercept. So we're going to use y equals mx plus b. So that is going to be my starting point, y equals mx plus b. Now to do this, I have to know what my slope is, and then I can go through and find my y-intercept. So to figure out our slope, we're going to go through and do m equals, again, y2 minus y1 over x2 minus x1. So if 5 comma 2 is my x1, y1, and my x2, y2 is 3 comma negative 6, if I go through, it's y2 minus y1, so negative 6 minus 2 over x2 minus x1, so 3 minus 5. All right, if I simplify the top, negative 6 minus 2 is going to give me negative 8, and then 3 minus 5 is going to give me negative 2. So negative 8 over negative 2, negative over negative is positive. 8 divided by 2 is 4. So my slope is 4 in this case. Now, if we are using slope-intercept, I have figured out my slope. Now I have to figure out my b value. So that means we're going to take y equals mx plus b. I'm going to plug 4 in for my m, and I'm going to choose one of these points. I'll choose the first set, 5 comma 2, because I don't want to use a negative, in for my m and my x. So this becomes 2 equals 4 times 5 plus b. So if I go through and solve, 4 times 5 is 20, so it's 2 equals 20 plus b. I then just need to subtract the 20 to the left side, so 2 minus 20 is going to be negative 18. So negative 18 equals b in this case. So now that I have my slope, I have my y-intercept, I can write this into y equals 4x minus 18. And then all I have to do is move the x to the left. So that means I subtract the 4x. And I end up with negative 4x plus y equals negative 18 for my answer. X and y are on the same side, the constant's on the other side, and I have no fractions. And that is how you write the equation given 2 points using point or slope-intercept form to do it. All right, now parts C and D are much of the same thing. It's just, again, they give you a different set of points. I do want to run through these just to give you more practice to see. If you feel comfortable with this, go ahead and skip to example 4 with the graphing. Otherwise, watch and see more done this way. So if we look at C, the line passes through 4, negative 7 and 2, negative 3. The first thing we need to do is go through and identify our slope. So we have to figure out what m equals. I'm going to move this down just a touch. All right. x1, y1, x2, y2. If I go through and find my slope, so that's going to be m equals y2 minus y1. So negative 3 minus a negative 7 over x2 minus x1. So 2 minus 4. Negative 3 minus a negative 7, so that's negative 3 plus 7. That gives me 4. 2 minus 4 is going to give me a negative 2. When I do 4 divided by negative 2, I end up with negative 2 for my slope. Now, from here, you can run through whichever method you would like. For this one, I'm going to go back to slope-intercepts, my y equals mx plus b. From here, I'm going to choose one of my set of points, plug it into y equals mx plus b, take my slope and plug it in. We're going to solve for b, write my slope-intercept form, and then change it to standard. So, let's go ahead and let's use 2, negative 3. So negative 3 is going to be my y. My m is negative 2. My x in this case is 2. So I have negative 3 equals negative 2 times 2 plus b. If I go through and solve, we're going to multiply this first. So we have negative 3 equals negative 4 plus b. And then we're going to go through and add this 4 to the left side because it's a negative. And we end up with negative 3 plus 4 is 1. So I have 1 equals b. I now have my y equals mx plus b. So I can write this as y equals negative 2x plus 1. And then to change it to standard form, we just have to add this 2x to both sides. And the reason I'm adding the 2x is because it's a negative, so the inverse would be addition. So if I add it to the left side, I get 2x plus y equals 1. And that is my answer in standard form, because I have x and y on the same side, constant on the right side, and no fractions. All right, last one. For D, Again, we have 2 points, and we have to go through and write an equation that runs through those 2 points in standard form. So I have my x1, y1 and my x2, y2. First step is to go through and find your slope. So it's m equals y2 minus y1, so negative 6 minus 5, over x2 minus x1, so negative 10 minus 1. If I do negative 6 minus 5, I get negative 11. Negative 10 minus 1 is negative 11. So negative 11 over negative 11 is going to simplify down to 1. So my slope is 1. All right, now that I have my slope, we can go through and use either slope-intercept or point slope to then change this into standard form. Because in part C, I used slope-intercept, I'm going to go back to point slope, which is y minus y1 equals m times x minus x1. So I'm going to go through and use that formula to change my equation. So we're going to choose a point, either 1, 5 or negative 10, negative 6. You should know by now which one I'm going to choose, which is 1, 5, because they're both positive and smaller. So we're going to plug this in for my x1 and y1, and then 1 in for my m. All right, so it's y minus 5 equals 1 times x minus 1. First step is we're going to go through and distribute this 1 to both parts. So we have y minus 5 still equals 1 times x is just x, and then 1 times negative 1 is just minus 1. Your next step from here is we need to add this 5 to the right. So I get y equals x, and then negative 1 plus 5 is going to be plus 4. And all I have to do is subtract the x to the left, and we end up with negative x plus y equaling 4. And that is our answer. All right, so I know this has gone on a while, but it's one that I really want to be clear on and give you a ton of examples to see. Now, I do want to just wrap up with example 4, which is going to ask us to go through and graph the following equations in standard form, or that are in standard form for this. Now, I'm going to reference back to section 5.2 on using intercepts. We have x and y on the same side. I can find my x-intercept and my y-intercept, and if you recall, we did that by the cover-up method. So I would cover up the y to figure out what my x-intercept was. I would cover up x to figure out my y-intercept. Plot your x and y-intercept, and you have your 2 points. So let's go through and do that real quick. So to figure out my x-intercept, we're going to cover up the y. So I have 9x equals negative 45. And if you recall when we did these problems, we would take this number and divide it by that number. So we're going to take negative 45, divide it by 9, and I end up with negative 5. So my x-intercept is negative 5. And next, I want to go through and find my y-intercept, so we're going to cover up x. So I have 15y equals negative 45. So we take negative 45 divided by 15, and I get y to equal negative 3. So my x-intercept is at negative 5. My y-intercept is at negative 3. X-intercept means we plot that point on the x-axis, so we go back to negative 5. Y-intercept is at negative 3, so we go down 3. and I have my 2 points. So then from here, I just connect the dots, and I'm good to go. Just like that. And that is how we go through and graph these equations that are in standard form. So you would go through and do the same thing for B, figure out where your x and y intercepts are, plot them on the x-axis and then the y-axis, connect your dots, and you have your answer. Again, use the cover-up method. Cover up y to figure out x, cover up x to figure out y, plot your points, and you are good to go. Now, I'll leave part B for you because it's a flashback to section 5.2, and it is done on my completed notes, so if you have any questions or are curious about what it looks like, be sure to take a look at those. Otherwise, that is it for today. I know this was a little bit longer video, but I appreciate you guys listening and really watching through the examples. You can use whichever method you prefer, whether it's y equals mx plus b, or y minus y1 equals m times x minus x1. Whichever method you prefer, that is completely up to you in your choice. Just whichever way you feel more comfortable with. But with that said, that is it for today. Thank you guys for listening. And that is section 6.3 on standard form, which is ax plus by equals c. So, have a great day. I'll talk to you guys later. If you have any questions, just shoot me an email or let me know next time you see me. All right, bye.